Thank you for joining the Once Changing the World, which is India's first Future Tech Meets Sustainability podcast. And today I'm truly delighted and honored to have with me Dr. Anirban Bandyopadhyay, who's a senior scientist at the National Institute for Material Science, Japan. He's recognized as the creator of the Nano Brain, an artificial brain which mimics the human brain, and is the author of Nano Brain, the making of an artificial brain from a time crystal. And he's also setting up the Quantum Computing Center at Mandi. So, Doctor, really appreciate you taking time and being part of the podcast. Why don't we start with a small, brief introduction, your background, and your journey in the field of science and technology?
Yeah. So basically, I wanted to build an artificial brain, and there was an international competition in Japan in 2004 when I was a PhD student in Indian Association for the Cultivation of Science, ISCS Kolkata, and I won the competition and became a faculty here in Japan. And for the last 18 years, I have been developing an artificial brain, and I'm continuously working on it. That's it. So my journey is very simple and brief, just from India to here.
How awesome is that, sir? You are extremely humble, but really appreciate you taking time and being part of the podcast. Now, when you say that you're making a human brain, a nano brain to be specific, would be great if you could elaborate to the audience, because I think brain is like a black box of sorts. We don't understand much of it. There has been various efforts in understanding it, right from the simple C. elegans worm, which is around 300 neurons, to a fruit fly, which is around 150,000 neurons, a rat, which has got 200 million neurons, a monkey, which has got 1.7 billion neurons. And then comes the human, which is some 86 billion odd neurons and 100 trillion synapses. So there's this human connectome project, which is trying to understand the connectomics of a human brain, but we are extremely far from something like that. We have managed to kind of understand the fruit fly. We now going to a rat. So when you say that you are building an artificial brain, kindly elaborate on that, because this so far seems to be the black box, at least in the mainstream media.
Regarding the C. elegans project, that's a famous project that we know. So I would just like to add one point to this project to support the kind of complexity that you have raised. That 302 6 neurons, and then what you do is you can map totally, and you allow it to fire randomly, but nothing happens. So basically, you have created an artificial model in a super computer. You have put everything, because all the genome maps and everything is done for this tiny little living spaces. And then when you give a trigger of energy trigger of the synaptic firing, you thought that because of the natural symmetry of the neural network, it will start generating lots of logical firing process in the system. It didn't happen. So that's why people started rethinking. For an example, connectome, we have now the map for entire brain body system 0.5 millimeter, that is 500 micrometers. Some of the cases 200 micrometers. So you can understand that I know the hardware very well. I know the behavior, I know the response of a human brain and everything very well. I know the fundamental properties of every single component very well, but I don't know how it works. How funny is that? This is for the first time in the scientific venture for humanity, we are encounter a situation then when we know the hardware structure very well, but we don't know how it works. So 1850, 1860, the mapping of the neuron and the structures started. Our brain has 47 different functional regions. That's called Brodmann's regions. And those mapping were completed in 1910. So, 1943, artificial neural network came. McLeod and Pitts, 1943, he proposed how we can create a neuron firing model, and AI concepts came up. With all these things, we don't understand the brain. My computer is 1 TB hardware, and then I have a 15 GB RAM and 2.4 gigahertz. I know synapses fires millisecond. I have the devices hundreds of picosecond firing. So we have a million times faster switches, more resources, but still we don't know what is there. Just to add to your complexity, there are people who has no brain. If you see the MRI image inside the brain due to hydrocephalus, it's full of water. There is a thin layer, and the person is very conscious, 44-year-old guy, and there are 2-3 kids from UK, and then there is one doctor who is a surgeon, no brain. There was a 23-year-old lady from China who went to the doctor, and it was found that cerebellum is not there. So the very fundamental concept that hardware produces the brain is also under challenge. So when I was giving a lecture, one person asked that, Anirban, I see a thin layer below the skull. Whole brain, there is nothing, but there is thin layer. Maybe the whole brain, because of huge plasticity, packed over there. This is a very nice question. He is a very senior professor. So with due respect, I told him that, sir, even though it is very thin, you can't pack. The packing density of neuron per unit volume, how many neurons would be, is fixed for a particular species. For neuron, rats have some, elephant has some, and all different animals have some density. You can't pack more. It's not like a puffed rice tin where you shake it more so that air spaces will get coupled. So time and again, the very fundamental principles based on which our scientific understanding we have made gets into a challenge whenever we do the brain research. But that's what haunted me, because I thought that people are not looking into the right place. They are trying to find information maybe in the hardware. Maybe it is somewhere else. And that's how my journey to the brain research started.
Right. So maybe, Doctor, I would like you to elaborate on that, because so far I think the common knowledge is that hardware has everything. Now you are saying it a counterintuitive thing that maybe it's not the hardware. So and obviously, when you talk about consciousness, I mean, there is no common ground where the people fronting this the consciousness have come and said, okay, this to define consciousness. So there's no true definition of consciousness itself at this point in time. So where do you start with, when you think about building a nano brain, when there's no commonality whatsoever in the world? What was the source of inspiration? What was the start for you to go about and saying, okay, this moonshot or building a human brain is possible and you're going to go for it?
Because at the age of 12, my father gave me a book. The name of the book is Brain, and it was 30 years of research compilation in the it's USSR. When we were kid, then Russia was not there. Because I grew up in Bengal, so we had a communist rule. So Russia used to send lots of research articles translated into Bengali and to our place. So very, very advanced research in very simple forms is to be written. And at the age of 12, I got, and I read about hippocampus, that beautiful spiral networks are there, and then current goes. And then automatically a number of rings means go here, go there. There are 47 regions, one for language, one for my pain, my sound, my cognitive ability, all these kind of things. So there is a hippocampus, a tiny little thing at the top of my spinal cord, which is called pons, and it is there. And then I was to see those components, and automatically it is programmed to generate beautiful set of organized behavior in the brain. I used to see the brain signals. So from my childhood, I wanted to build a brain. How difficult it is it's a thing. When you dream, you do not dream because it is difficult. You dream because from every part of your body, every single particle, every single vibration tells you this is yours. That's why you dream it. So I was not trying to make a moonshot. I was stupid. I loved it, so I wanted to have it. So I wrote a project proposal. I was playing in the playground in cultivation of science. Somebody came and told me, in Japan, there is a competition. They are selecting crazy guys from all over the world who have the crazy ideas. And then 2060, any idea you have to give. And they are looking for at least 4 years or 5 years of postdoctoral experience or assistant professors. But you always are so crazy about research. Why don't you apply? Do you have any project? Today, 11 o'clock is the last. So it was 5 o'clock. Within 6 hours, I wrote Artificial Brain. It was not difficult for me to write. I was writing every single vibration I had within me. So I also got the chance, because they break the rule. I didn't have a PhD degree. I got a position here with assistant or associate professors and other people from all over the world. So 24 countries, 40 people were selected. They selected me because I had the passion and I had the love and I had the dream with me. So when I came here with all this artificial intelligence and all these kind of things, I was big fan of Stephen Wolfram and a new kind of science, cellular automaton. In 2002, the book came, and then I took a leave for 3 days and I didn't eat anything. Whole book I read, so something like this. So I always read books like that. So I was believer, and slowly I understood nobody understands the brain. And I also understood a very shocking and surprising thing, that neuron is a living cell that looks like a teardrop. Okay. And this teardrop like cell that gives me thought process, makes me intelligent. And neuron, I knew neuron since my childhood, because I read about it so many times from my father, because only book I had in my house was brain and brain science and astrophysics. Always it was kind of filled in my house, and my father used to spend a lot of money for me for my passions. So when I understood that 1906, a French scientist, Lepic, somehow said that this neuron skin is doing everything. And in 1952, Hodgkin Huxley said that the neuron skin is actually doing the information processing. So look at the skin. I am holding this bottle. I can say that Anirban's skin is holding the bottle, but there could be other interpretation also. I was surprised why scientists are not doing it. But I was a physicist. I didn't know how to culture a protein, how to culture a cell or something like that. But NIMS-like institute has an advantage. Here unlike India or any other part in the world, in Japan, what you can have is you can have central facilities at many different places in the institute. Whatever you want to do, I could go, oh, you want to work on protein? You need a -80-degree refrigerator. Do you have it? No, I don't have it. So we have 760 faculties, more than 500 engineers, top class engineers who are doctorate and one of the finest. They have 30 years of experience. They are sitting over there, and then they tell you, oh, you don't know? This is -80-degree fridge. You have to do this like this. I wanted to touch it. I said, no, you will be burned. You have to hold like this. So anyway, so my experience started, and I started thinking that neuron is not doing the information processing. I have to go inside. And I went inside. I took out the material. I had the experience for nanotechnology, because nano devices, atom manipulation with scanning, tunneling, microscope, quantum pictures, I knew very well. But from there, going inside neuron and trying to find their nanowires, packed nanowires, helical, and then helical structures moving signal from one to other direction, I was amazed, because from my childhood, another thing I loved very much, spiral, helix, because in astrophysics, all over the universe, wherever you look with a telescope, you find the galaxies are always spiral. your DNA spiral, your protein, you have a alpha helices. So spiral somehow haunted me. And then by 2010, I filed a patent that a spiral device is the fundamental device. It's not neuron, it's not anything, spiral symmetry. Just like alpha helices, you have helix. Why nature choose helix? Because if you send noise, because of the helical path, the automatically allowed signals will be selected. So you can live in the noise and you can emit, you can radiate like an antenna. So you don't need circuit. So I always believed circuit is the stupidest thing that we try to enforce on the brain. In 2014, when I was a visiting professor in MIT, USA, then I sliced brain myself just for the reason I wanted to understand, because I wanted to build the artificial brain. So I wanted to understand how it looks like. And then I found one neuron is going inside another and coming up, and then all these kind of things. The guy who proposed in the 1991, 92, those people who proposed this brain as a circuit, with a circuit model brain, is a circuit made of neuron, it's a switching transistor-like thing. They never saw the brain. They never sliced the brain by their hand. So make long story short, I started looking into the vibrations, because in my PhD, when I was doing PhD in India, one thing I realized that this pump probe type thing, which is going on in the scientific practice, I want to understand this bottle. I will throw a stone and it will shake, it will emit some energy. And from this emission, I will be able to, so pump, probe. This is the fundamental experimental process that mankind is using. I didn't believe it. I think this is the stupidest way to understand nature and its fundamentals. We have to understand its language and we have to speak in that language. So when I came to Japan and then I started performing well, then they gave me a lot of money to build an instrument of my dream, massive instrument I built. It's an ultra high vacuum chamber, quantum tunneling system is there, but you can vibrate a nano system at different frequencies and you can observe quantum picture. And then I found that there is a music, hidden music in it. This frequencies dance like somebody's playing piano, and they change their shape and the conformation. So music and dance become an integral part of nanosystems. Then I grew up at all higher scale. So then I came to understand that it is in the structure of time. So one of the fundamental difference between India and the rest of the world is, in India, time is circular. We say Kala Chakra. For thousands and thousands of years, time is always circular, loop. And in the Western world or anywhere outside the Indian boundary you go, time is linear. It goes past, present, and future. We don't have it. We have circle, 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 circle. You will find that we put a lot of clocks together and arrange together. So it means my brain model in 2016 became a lot of clocks arranged together. So I can bring it here. It's just here. So this is the meninges, and these are different three different big balls are there. So 3 different clocks, and they have 4 colored balls. And you have basically 12 different triplet or triplet clock architecture. So whole brain software is like this. So maybe you don't need the whole hardware system. So I would like to show you also how the brain looks like, because you should see it. So this is the brain. So you can see it. There is a connectome, spinal cord, and a hand, leg, interneural network is there. And this is the brain jelly that we created. I can touch it and you can feel it. And you can see in my lab, 2 brains are communicating, artificial brains, and then those signals are there. I can see it from far. So to put the story again, to briefly, how the space looks like, the circuit doesn't matter. When they vibrate, and in the time domain, the architecture that is they are making, you have to find the brain nature and its intelligence over there. That's all I have to say.
Right, right. So many interesting things I would like to take from this. So maybe I would like start with like being crazy. I think what has happened in the field of science or any field is that we become very safe. We do not take these brave bets, and we don't go out against the system, because I think when you push beyond what the general consensus of things is when you actually truly find the answers. So kudos to you for going against the pack, and while the world is zigging, you're zagging. So I mean, so kudos on that. So many things that I would want to unpack. A, the vibration. B, everything is spiral. But before I get into that, that hidden music and dance that you getting into when you kind of deep dive into the neurons and understanding all the spirals in it, I would want to open up, the others in the world, the peers who are looking at the brain. There's obviously AI, the field. It started with us, trying to emulate the human brain. We started building neural networks. Then there is, over the point of time, we've got neuromorphic computing, where we're trying to build brains, which has got, build computers which functions like a human brain. Then there is Henry Markham with the Blue Brain project. He's trying to create a complete simulation of the entire human brain. And then there are these biologists who's kind of tinkering around and building organoids, where they're taking these stem cells and culturing it. And through the stem cells, they kind of culture it into a mini brain of sort. But you have taken a complete different approach. So you gave a lot of information. Maybe elaborate a little bit further on that. You showed your current prototype, what you're building. Maybe talk a little bit about that. What was the building process, the challenges, and once you build it, what can it do at this point in time?
Yeah. So basically the difference, you mentioned Henry Markham. In 2012, I organized a conference. I invited those guys who were telling that they will build a brain within 10 years. So there was a huge movement in 2012, 2013, when Europe wanted to build brain, China wanted to build brain, Japan wanted to build brain, and all of them spent more than billions, $2 to $3 billion, not million, $1 billion at that point of time, to build an artificial brain over 10 years. If you look at all of their proposals have one thing in common. Neuron is a switch or a transistor. Brain is a circuit. And if you have a super computer, it's just a matter of money. Then you can upload consciousness in the computer and you can do everything. But that time I was in MIT. I went, and Noam Chomsky stood up and asked 4 questions that you are going to waste the entire humanity's money, because for the first time humanity came together and spent on a single project. I repeat, on a single project, they spent more money than the defense budget. So defense budget has many small projects for making particular type of product. But for individually, just one project, America had Obama initiative, and all the projects will be finished in 2024. And we all know they build nothing. So I invited all of them and then asked them that, how are you going to build? From Tommaso Poggio from MIT came here, and then Blue Brain project, all the big shots came, and then Hugo de Garis, I know personally, who was responsible for Chinese brain project, and also Ferdinand Pieper, I worked with him, who started in Kyoto, Japanese brain building projects. All of them, neuron, circuit, device, and something. But our case, who is responsible for consciousness? We don't identify any device. We say, for an example, you and me have a conversation now. Our conscious experience is say 50 milliseconds or 100 milliseconds. But for that, your neuron is firing 1 millisecond. But for that, inside that, microtubule is firing for microseconds. Tick, 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 tick. For that, the neurons, the alpha helices, the cavities inside the protein are vibrating tick, 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 tick in nanoseconds. For that, the alpha helices that are there, every picosecond, tick, 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 tick. And for that, inside that, femtosecond. So you go 3 orders below, there is a clock inside, 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 a clock. So when I showed you the brain, one magical thing that you saw, that I didn't show you the neuron. Neuron, we have single molecule, we grow them, neuron-like structures. I can show you that. So from the molecular scale, we grow up to millimeter scale. We can make the nanofiber, and we create the entire neural network, and we create the entire brain body system. So 47 different kind of organic gels. We have organic gels we have synthesized. They are all vibrate like a musician, helical symmetry and different kind of symmetries. They go from the nano scale, single molecule scale to that. And then they grow up. But they vibrate at all the scale like the clock architecture. Many clocks put together, and they are there. So they vibrate just like that. So the difference between them and me is, I don't say that consciousness is here. Like if you go to Christoph Koch, who is running Google's artificial brain building project, of course, all of them are failing. So now no problem. 2024, there will be an official announcement that every single attempt failed. Because of the 4 questions they never try to answer. What is information in the brain? So we say that it is the structure of clocks, the symmetry of the clocks. So triplet or triplet, I say 3 big clocks, and then each clock have 3 more clocks, like second clock, minute clock, hour clock. In this way, from top to the bottom, this kind of clock, we say polyatomic time crystal, or time crystal always means that a lot of clocks are together in the phase singularity point. If you have a big sphere, you have some dark region, and you can put another clock. So that is your information or invariants that are forming. What is your elementary device? Spiral symmetry. Wherever you see, that is your information processor. So you never say that it is here, 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 here. Wherever is there, like a neuron, glial cells are all around it. For one neuron, you have 100 glial cells making a spiral around it. So they are also doing it. Inside the neuron, microtubules are following vortices like this kind of arrangement. Inside the microtubule, their proteins are making helices. So nowhere it stops. The helicity, and then helicity has the advantage of creating triplet or triplet clocks. That means 3 big clocks. That means millisecond, microsecond, nanosecond, and then in millisecond also you find some 3 different clock regions. So so this is how the information integrates. Then the question is, what is the how the information integrate? Then we say that it is prime numbers. For an example, 47 different regions are here. Brodmann's region, 47 is a prime number. If I say how many spinal cord nerve branches, 31. You have all studied in the book. 31 is a prime, 1 is a prime number. 43 branches are there from the hippocampus spreading all over the brain. 43 is a prime number. The microtubule has 13 protofilaments, prime number. You have 200,000 cortical columns on your brain to give you the thought process. Each cortical column has 7 layers. That is a prime number. So if you take only 15 prime numbers, say 2, 3, 5, 7, 11, 13, 15, and up to 47, then you can see that just combining their vibrations, you can possibly generate 86% of all possible vibrations in the universe. So this is how information integrates. 4th question, how it becomes self-aware. So that question was most difficult part and biggest challenge that I have to understand, because now we created a temple-like architecture. I hope if I check out my book, so if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in this way. And then 12, how many ways you can arrange? 2 into 2 into 3, 3 into 2 into 2, 2 into 3 into 2. In this way, how many ways you can arrange? You rotate them, you get a temple-like structure. So that is how the information integrates, the core. So this is cover page of my book. And sometimes I call this as Purusha and call this polyatomic time crystals as Prakriti. So this is integration. But the final thing is that with 15 primes, I can create like C2 symmetry. If you cut by half, this part, C2 symmetry. And C3 symmetry is 3 different parts. So how many objects in the universe have follow C2 symmetry? Look, there are 23 Bravis lattice, 23 type of symmetries, and you can explain all possible materials in the universe. So if you look at the varieties, facts, information, don't go there. You will die. You will not be able to fathom. But if you go to the symmetry, you can convert all possible varieties into a few simple things. Similarly, C2 symmetry, if you divide by half, this part nearly similar. Then C3, how many objects? 16 billion years before, 50% of the objects were following C2 symmetry. And 16 billion years later, when humanity will not be there, even then 50% of the structures will be following C2 symmetry. Then C3 symmetry, 16%. C5 symmetry, 8%. If you go on adding, you will reach 86%. So it means me, whoever I am, if I am made of this kind of prime-based mathematical structures, that is, my vibrators are following like that, I will be able to understand your concept of whatever you create or anybody create if you are also made of like that. So there is somewhere a mathematical core architecture that has been created, that has created the whole universe, and I can understand 86% of it with my vibration synchronizing with it. So that is the answer to the fourth question. So these four questions were not answered in the other brain builders research, which I tried to address. I'm not saying I'm absolutely correct. Many part of it will be proved wrong and then readjusted, but something will never change. That is the way people looked at absoluteness. That, okay, if Christoph Koch claustrum is responsible, a particular component in the brain is responsible for consciousness. If you go to Stuart Hameroff or Roger Penrose, microtubule is responsible for consciousness. If many people, synaptic junction is responsible for consciousness. Some other people have some other portion, say hippocampus is responsible for. Some people brain stem is responsible for consciousness. So everybody is going to some component and trying to find consciousness over there. But where we are saying, never look at space, look at the time, architecture of time. And we Indians are mastered in it for thousands and thousands of years. We always architecture of time, rhythm, Chanda Upanishad, Chanda Sastra. We have created so many books on rhythms. So many. Even in 15th century, you will find scholarly books were written for rhythms. When the whole world was in the darkness, era of darkness, we were writing the books on mathematics of rhythms. No other race in the world you will find have spent thousands and thousands of years relentlessly investigating and understanding.
Right. Yeah. So I think it's surprising that, the Indian Upanishads had so much of deep knowledge over there, but sometimes, I mean, it feels like that we have lost it. Even the music. I mean, I think jazz is one form of music which kind of plays around with a lot of different time signatures, but I think there's no music format then Carnatic, Hindustan Carnatic music, which kind of plays with different time signatures in such an insane mathematical way. Now you have designed these organic brain jellies that you claim that can learn, that can program, and then solve problem. So can you elaborate on this unique material? How does it work, and what are the implications of it in the futuristic future, like with robots and AI?
Just to get into the mathematics, when I first measured the frequencies, I put it on this paper. This is a historic paper I have kept. So you can see lots of vibrations are there. And this is a very long paper. So I never understood. For years, I used to keep it on the passage. And I used to look at it every day. I used to come to lab and then try to understand in 2011, 2012, 2013. And what I found, there are 108 different frequency. Triplet of triplet is 9 and 12 bands, that I always say, 12 time domain. That's why I have created a new instrument. You saw when I showed you in the video, a artificial brain was reading, wearing a machine. We call it duodecanogram, DDG. That means 12 different time bands are there. So 12 into 9, 108. So when I was giving this lecture in 2012, 2013 in the United States, a Jain person came and then gave me a book that have you read this book? That is 108. And name of the book is 108. I have not, but I see 108 pics over there. And then that changed my life forever. Because until then, I did not have that much respect for, I mean, I don't want to get into this debatable thing, but since my father was an atheist, and then I'm also, still now I believe in Sankhya and Sankhya Darsana. I challenge God, just like Maharshi Kapil. He said whole universe is a mathematical structures and something like that, and Sankhya something like that. So that's I mean, Vedas is a book for atheists, like who is going to challenge the existence of God. so Veda starts from there, right? That before the creation of everything, who was there? And God, where are you? They say that you know everything. If before the creation you were not there, then do you know everything? So I mean, I'm from that path. So when I hear 108, I called my mother and I asked, do you know 108? I said, yes, in Rudraksha, there are 108. Krishna has 108 name, Shiva has 108 name. The Nataraja dance form has 108 8 different kind of formats. And then I'm a tabla player. I learned tabla, and I learned about tala, which is 17 or 21, 23. But I met with a South Indian musician, Carnatic musician, and he told me, no, Anirban, you are limited. There is 108-bit tala. In South India, we have. So 108 tala, 108 raga. Raga, you see, they say 14 lokas of Shiva. So Shiva 7 into 7. Aroha, sa re ga ma pa da ni sa, sa ni da pa ma ga re sa. So sa. So those two sa common. If you leave, you will get 12 notes, and you twist them a little bit on a circle, and you get a different kind of fractal pattern that you expand to get the music. So our food, our dress, our music, our every single thing in our culture was fundamentally studying this vibrations that we see now in the proteins. So when I made the artificial, I now get back to your question. When I made the artificial brain, my objective was nothing. Was I put a 12-band machine, dodecahedron machine, on the human. I will look at the 12 time domain. As I said, that one time domain EEG was discovered invented in 1875. 150 years, humans all over the world. If you have a mental disorder or any kind of problem, people put EEG device on your brain and you measure 1 to 40 hertz. But I measure 1 to 10 to the power 12 hertz, because no frequency is important, no time is important. Different pieces of time, they are creating a pattern that is important. So I wanted to have absolute brain, absolute replica brain, which vibrates exactly same as this, to put, so there are two brains I showed. So one should be the brain, and the other one should be the artificial brain. So if two are there, then what we would do is, with respect to the artificial brain, we will compare the human. How is it different? Can we find out how you are communicating with the universe? So I never wanted to do business. Business was never my objective. I'm not a businessman. I could have spent money in share market. I saw in India, this time I went, many professors from different IITs and top research institutes, they have a mobile phone app and putting money into share market. Tack, whole day, 15 seconds. I never did that. Here also, I see people, scientists are doing it. I never did it. I don't. Possibly I will never do in my life. But so what I am going to gain by making artificial brain, I don't see it in terms of it is my life. And what I want to see is I will go towards the brain's vibrational time architecture as close as possible until I die. So if I have the artificial brain that has the architecture of time, and human brain has an architecture of time, what is that is making different and separate and special? I feel if humanity can make very close vibrational structure, polyatomic type structure, clock architecture of artificial brain, then they can find out how exactly we are communicating with the universe. For an example, if you go to India to US, you will have a jet lag, 12 hours gap, and then you'll be there. You'll be sleeping in the day, waking. That means what happened? The sun clock and the moon clock, and then the water level clocks for them is connected to your body. That's why you need to readjust your clocks with the superchiasmatic nuclei that you have. You need to adjust that because the biology, circadian rhythms and all kinds of rhythms. There are many different kinds of rhythms. That's not the only one rhythm. Many plenty. You might be communicating with the Jupiter's clocks also. So when you have these kind of situations, how do I isolate them? Who knows? You may be communicating with the galaxies. Others, I will not look at the signal, just like they have made a massive gravity wave detector, but I will find a new different kind of clock that is being born inside you. So that is a very low cost way to understand the universe without going anywhere, just looking into your brain. So I will use your brain as a sensor to find out the clocks that are missing, that are universe is communicating with you. Because I feel, just like the Vedas, the whole universe is the Virata Purusha, and it's a big life form, conscious life form, and then there is a conscious life form inside, and then you take one and conscious life from inside and inside and inside. So definitely, I can use the brain as a sensor to read the hidden signatures of the solar system, of our galaxy, and maybe external galaxies, because they will change the clocks inside you.
Right. So many deep things you have mentioned. I don't even know whether we can get into and open up all of those, right from, finding 108 everywhere to, maybe the Shankya, that the whole world is mathematical. There's a book written by Max Tegmark that the universe is mathematical. Then there is Seth Lloyd, who claims that the universe is a quantum computer. So maybe if briefly you could kind of, give your thoughts on is the entire universe mathematical? And if that is so, are we living in a simulation? Maybe that's one question. And then you were having a talk with Dr. Deepak Chopra, and you were talking about setting up a global platform for creating a super intelligent molecular machine called Bramha. When you're talking about that Bramha, is it in the lines of Eric Drexler's vision of a molecular assembler? Is that what you're talking about?
Yeah. So we already have created Eric Drexler's version of brain that is actually called the Nano Brain. So I built it in 2008. A small molecule and 16 molecules all around, because I felt that Eric Drexler's 1989 proposal is incomplete. He wrote the whole book, and after that, molecular machines were invented and people came into what they never made. Is I have written in the PNA's paper in 2008 that why not you are talking about brain at the nano scale? Somebody has to make the intelligence. So I had Dr. Subrata Ghosh, who is now a senior scientist in CSIR NEIST, and together we built a dendritic molecular system, just almost like the Drexler's vision. And we have nanobots all around, and then we have sensors inside the decision making together, all together 10 nanometer. And in this molecular version was when I was giving interview to the BBC, Jonathan Fields, I think. And then he actually said, so Anirban, can I say this first nanobrain in the world? So that's how the nanobrain word was coined. And Bramha is a concept, is that I'm still working with my PhD student, Sudeshna Pramanik, who is working, trying to understand. For an example, if you think about string theory, so they say string is the fundamental of the universe. We say that spiral is the fundamental of the universe, geometric phase and others. Now, in string theory, you have 4-dimension tensor, 4x4, and then 8x8, and then they do it together. In our temples for thousands of years, we have Chautisha and Astisha. Chautisha is 4x4 tensor. You will find it is written on that South Indian temples because, South India is the storage of the remnant of the Indian civilization that we had. In North India, almost everything got destroyed and disappeared. So you will still find that a Chauti, and 1800 it went to the west, and then they even satellite telecommunication to your mobile phone communication to weather forecasting, everywhere this 8x8 and 4x4 tensors are used, which is called quaternion octonion. If you want to understand the universe, then you have to know 4x4, 5x5, 6x6, 7x7, 8x8, dot 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 53 cross 53 dot 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 up to 108 cross 108. So this massive multi-dimensional tensors, why they are beautiful, why it attracted Einstein in 1913, and he learned from Michael Grossman and proposed the theory of relativity, because you can 4 imaginary world by 4 imaginary world. Third imaginary world can interact with fourth imaginary world and give the result in the first imaginary world. Imagine you and me sitting maybe different universes, me and you interact, and then other universe, somebody else was sitting, some idea comes to his mind. This is the beautiful world that is inside us. It is in the textbook, but we don't read it like that. But it came in the 1920s. So what I'm doing now is increase it up to 108, so that with the tensors we can rewrite the kind of universe that we want to see. So the Drexler's molecular universe we have already created in IIT Guwahati, Professor Ajay Kumar Kundumakkara and from Kerala, and her student Parama, they are now testing the genetic modifications that we can have if we put that nanobrain. So we are looking for a futuristic society where we will give that nanobot and we will do the molecular surgery at a particular places where we can intelligently program it, and it will replace the method of surgery. Also in IIT Kharagpur, Jimli Sarkar and Ayan is working. Ayan Chatterjee is working on the intelligence of this kind of nanosystems. So that is actually different part of the work from the nano brain. Then I will move to real brain actually. So
Dr. Amazing works that you've been doing. Now, India has been really driving the conversation when it comes to quantum computing, because globally I think there is Google and IBM who are leading the race when it comes to quantum computing, and there are nations also who are pushing forward the conversation of quantum computing, and so is India. India has got this India Quantum Mission, and you are now responsible or heading the Quantum Computing Center at Mandi. Can you first maybe kind of explain what a quantum computer is? How does it work? And maybe talk about elaborate on your partnership in setting up this Indian Quantum Computing Center at Mandi.
Yeah, so this is IIT Mandi, and Professor Lakshmidhar Behera, the director of IIT Mandi, he came here, visited us, and then he wanted to see what kind of computer is this, because I am making computers, brain-like computing or decision making since 2005. And even my PhD was on supramolecular electronics, that if you have a supramolecular system, many decisions are together, then how do you make a decision like brain-like system? What is, since it is said that even the senior most professors of the world, they don't understand quantum mechanics. And one Nobel laureate famously said there are only 2, 1, maybe nobody understands quantum mechanics, something like that. Or maybe I can say maximum 4. So what I would like to say is that first, what is quantum mechanics? Okay, so quantum mechanics is about a shared universe, shared world. For an example, I have two bottles here. In the classical world, they can exist, they have their separate identity. But suppose I can have 1 liter here and 1 liter water here. So if I measure in the classical world, it will be 1 liter plus 1 liter, 2 liters. But in the quantum world, if they are entangled, I will measure 1.2 liter here and 1.2 liter here, because the existence is shared. So totally I will get 2.4. So 2.4 is greater than 2. So this is inequality. So this is called Bell's inequality. So existence is shared. So like if I give an electron to a molecule has 20 atoms. So different atoms will take different part of the electrons. So existence of that electron is different part. So that means you are going through a road, and then your hand is somewhere, leg is somewhere, everything is somewhere distributed. So something like this, but there is no road in quantum. So if you have a sharp nail-like path where you can exist, and there is another one. Now, in between this, you can jump. Jump is a classical concept. You can't jump in the quantum world. So you disappear here and you reappear over there. So that is the beauty. So you can exist at multiple different places, but your replica cannot exist. So there are entanglement. Entanglement, again, people misunderstand. Misunderstand means they think two things are entanglements, everything is entangled. No. Only one property is entangled. All the properties you cannot. Only phase is entangled. Only one property. If you make multiple properties, all the properties entangled, then there is a prohibition in quantum that you cannot make an absolute replica of one object to another. If you do that, then you violate the fundamental principle of existence of the universe. So this is all weird things about quantum. But if you remember only one phrase, then you will never be fooled. That is, existence is shared. And energy is not required. You can vibrate here, vibrate, and you can appear somewhere else. Remember this, because quantum tunneling is about less than the. Why am I saying quantum tunneling? Because Indian professors will start shouting that without energy violation principles, very difficult. Because I'm talking to Indian professors now. Now I have a very difficult time. Because one professor told me that quantum interference and classical interference are same. Anirban, we have really. Anyway, other professors, I mean, I am listening so many funny things. Okay, so if two objects, electron comes from here to here, so energy could be less than the barrier. It can vibrate, it can vibrate, and then it will disappear here and come here. So that is called quantum tunneling. So these are the very basic concept of quantum. Now, when computing comes, then as usual, whatever the classical phenomenon is there, so scientists find a quantum version. What do? They share the property between multiple elements and then think that quantum has been achieved. So if I can share somehow, then I will do. So this is how in the last 100 years, we created every single analog of classical phenomenon into the quantum world. So if there is a classical computer, then why not we have a quantum computer? So that's how the concept of quantum computer came. So in the source algorithm came in 1996, and then other kind of ideas came that, look, if I can share the existence of particular choices into many things, and I can collapse them, and I can make a I can compute instantly. So these are in the popular media you will hear. What they don't tell you that how do I split my whole body? How do you know I am the solution, and you put it at a different place? So this question, Scott Aronson, I think, from MIT,
Scott
and
Aronson.
Joska, then Joska and Rape, and then others, 2007, 8, 9, 10, there was a movement. They looked in deeply into the algorithms, and then they found that, look, it is not that easy. If you go from classical to quantum computer, you will not always get advantage, because if there is a calculations, you need to break the entanglement and then re-entangle. So most of the problems you need to break entanglement, you get some derivative, and then you take some other derivative and calculate. And then like our arithmetic in the school days when we were little kids, we do little calculation, we get some output, we add with something, and then step 4, 5 steps. Then what will you do? Because every step is different. Factorization you can do very fast, because it's the same process you are repeating. So I started building quantum computer only because I found a language of nature. And that language was beautiful. That time crystal, as I said, different clocks are together, and then clocks are coming together and glued, because where there is a phase singularity. Singularity means everybody knows singularity, because everybody knows black hole in India. Whenever I go and talk, say singularity, oh, you are talking about black hole? Even the kids know this. So, if there is a singularity and another clock, and the clock gets in, and then you can create a clock architecture. That's like a glue. You can consider those as phase sphere, almost like a block sphere, and integrate those block sphere possibilities into a chain. So I was already doing it. So when I was building this neuromorphic computer here, so some professors came and visited my lab, say, Anirban, you are writing the information using microwave wirelessly in the organic or brain jelly, in the helical nanowires. And those helical nanowires are actually getting the information from outside, and you are reading it with photons. So if there is single photon and you have a photon counter detector, you can do quantum computing, because these all systems could be quantum mechanically entangled. Why don't you go for that? So that's the reason I went into this, and then I built one. It's a DOF type quantum computer, not logic gate type, because logic gate type making is very, very difficult. And I also don't believe logic gate type quantum computer would ever be realized. There is a reason, because nobody knows. In India never built a classical computer. And now India is dreaming to build a quantum computer. So classical computer, those people who work on qubit, I can tell 100% assurance I can give, by 2031, no group from India will be able to make quantum computer. Just like I said 2014, that by 2024, no group will be able to make artificial brain, even a neural network that can make a decision they can't make, because they are not addressing the question. Making a computer and making a logic gate is a two different thing. Making an adder subtractor is a different thing. It is not a computer. It is not even a calculator. So why it is difficult? Why it is not possible? Why it is critically challenging? Because in this computer that I am using, this computer has 1 billion lines of codes, developed over years after years. Thousands and thousands of engineers have worked on the modules. And there is a 2.4 gigahertz processor. There is a clock. So hundreds of picoseconds, there are pulses that are generated. Those pulses integrate clock up to the second scale, when an hours scale. That's how I can do the operations on this computer. In quantum, and today we are doing this interview, few days back, just 2 or 3 days back, a research report came from one of the top universities in the US, that quantum clock is very difficult to build. Because many people think quantum clock will be just like classical clock. Oh no, let's put some H cut. If you put some H cut, put a big Hamiltonian equation, and you think that I am able to do quantum. But the problem is that qubit can be entangled. You can take another qubit there and then collapse other side of the universe. So I had a long conversation with an engineer yesterday who is associated with this quantum computer building in UK. And then we were discussing, and then we were telling that clock, you cannot do that. So how can you make a quantum clock and integrating the time and keeping the time up to the classical scale, right? You have to do that. Like classical computer, 0 and 1, 0 volt, 5 volt. After a few distance in the circuit, in the wiring, what happens is 5 volt becomes 3 volt and 0 volt becomes 2.8 volt. So you do the error correction and put them back. In quantum, same thing happens, because the waveform that is there, they decohere, and then they develop errors, and you need to correct it. So one centimeter square of a Pentium 4 processor has 10 kilometer wiring, and you have to have major resources go there to do these corrections. Now in quantum computer, when you increase in a massive scale, you have exponential increase in the number of quantum error correction needed. So first challenge is clock, an incredible engineering and discovery innovations needed, but nobody talks about quantum clock because nobody has ever built a classical computer. They have not seen how the classical computer is built. So nobody is talking about. If you see quantum mission document for government of India, clock is not there, as if it is not required at all. But they are talking about logic gate based computer. So what we have done is a very different kind of thing. We might not have much time to discuss about it. I don't know. If we have time, I can certainly discuss about it. There is nothing secret in me. But in IIT Mandi, we are creating one of my students, Dr. Puspendra Singh, who built the quantum computer here. He is going to join there as one of the faculties. And then we are setting up. I am very, very determined. I did nothing for the country. I stayed when I was very young. I came here. In my PhD, I went to UK in Sheffield, and then I came into Japan and I settled here. This is my time to return to my motherland. And we will be building a quantum computer, the computer that I have built here, much more advanced version than that. And two dream of government of India that they wanted that we will realize. First is creating all technologies, the background technology, like jet engine. Why India couldn't build the jet engine? Because the associated little components, that technology didn't exist. So you can't integrate it over there. So I have decided, already made the plan, detailed plan, already purchase has been made. The Professor Behra, the director of IIT Mandi, is kind enough to provide the budget, and then the center has been created, and faculties are being recruited. I'm not involved in the faculty recruitment process because I want to avoid from that, but I'm directly involved in creating students whose mindset is engineering, and every single component that requires millions of dollars, we are recreating it in IIT Mandi. For an example, single photon detector. So Germany is now the best in the world. PicoQuant company makes one of the finest picosecond resolution to understand quantum entanglement. We are making it in IIT Mandi. Single photon avalanche detector to understand the single photon as a right or entangled photon as a right. We are doing it optical based because we want to do it in room temperature. Cryogenic we are avoiding because cryogenic, you can understand $30 billion. Microsoft budget is $30 billion, and they want to, they already spend $9 to $10 billion, achieve nothing. So what will happen to the $1 billion of government of India total budget if they give it to the qubit makers? You can understand. But we want minimum amount of money from the government of India. We will apply. If government gives money, okay. If doesn't give, still we make it. So the cost and other things we have calculated in such a way that we will not be waiting. But we definitely want that all top professors who are making qubit in India should be given money from that $1 billion. The reason is that the nation should see that how an innovation is made. Because Indian scientists, top professors have always complain that they are not given money. That's why they can't do the great thing. But they forget. I mean, I posted in Facebook 10 different discoveries which were less than $10. Andrew Game, he took a sellotape and took the HOPG out, and then he created the graphene. Research come from attitude. Research never come from. At 1880, where were the resources for Jagadish Chandra Bose? When he created crystallograph 10 to the power minus 9 to 10 to the minus 11 10 to the minus 11 meter vibration, he measured at that time sitting in Calcutta. I want to see how many Indian scientists have created that level of resolution even now. Right. We purchase that kind of sensors from outside. But if you want, you can build it. Definitely you can build it. I have seen it, many professors doing it in their lab. We are sitting abroad, and Indian professors always complain that you have lots of budget, and that's why you do it. If money is given, money has nothing to do it. So that's why it's a big challenge for me. You said, when is the good time to do, you sometimes you raise that issue. Actually to do great research, the best time is now.
You rightfully pointed out that money is obviously is needed, but it's not the first thing. I think first thing comes with that complete desire and passion and relentlessness of going out and building it out of true passion, of the reason of doing something which will serve society and change the world. And I think we're sitting at a cusp of point in time where all these tech stack are converging, and things are getting democratized. And yes, quantum computing is so core. I mean, if India really puts its money where its mouth is and supports the entire ecosystem, we'll truly have a computing device which could completely change the world. When you are describing quantum computing, when you're explaining quantum mechanics, you are giving the you're talking about superposition entanglement, and you spoke about shared existence. So, do you believe Hugh Everett's interpretation of a many world theory? Is that what you believe in? That's my first question. And the second question is, when we have what's the timeline that you're giving of building a working quantum computer in India? And once we have that, what would be the applications of the?
Okay. Two things that we are doing. So I must tell that this whole mission is not led by me. The mission is led by Professor Chandrasekhar Yadav, and he is a faculty and he is chairing the Center for Quantum Science and Technologies. We have Professor R.P. Singh from Physical Research Laboratory. I have talked to Dr. Balaji Srinivasan from IIT Madras to create an analysis. So we are contacting many professors from all over India, and it will be a truly national mission when we are building it in India. So it will not be effort of mine only. It will be effort of many professors who are there. We are talking directly. So we have been working for 1 year finding out those talents, because there are talents. It is not that there is not. Only thing is that those are never given honor. 1986 STM 1984 STM was built, but 1989 some people in India, and their handiwork, they built the STM, but nobody knows about them. I mean, nobody knows. I know because of personal reason. I came to know, and they told me, so that's why I know. So there are people who take little things, we say jugaad technology, and then with the jugaad people do. But the point is, jugaad should be the mainstream. Jugaad should not be the outlaws. So regarding the application, we have made very clear we are not going to go for logic gate based computing. Why? We will try. We will have a laboratory. We will have logic gate, quantum logic gate, like the other groups are showing. We will also show quantum logic gate, adder, substructure with optical structures in room temperature. We will show entanglement and other things, but we will not go. Why? Because these clock principles, when you do the hierarchical integration, where you give an input and you get an output, what I want is already in my lab. If you come here, you can use it, and videos are there in www.nanobrain.org. In this website, we are uploading the operations and how we are doing it, and everything is public. What I'm saying is that it will be almost like D-wave quantum annealing. So when I talk to Indian professors, they are already very much accustomed with the Brahman and Sudra concept. So if you are doing logic gate, quantum logic gate, then you are Brahmin. That is the true quantum. And if you do quantum annealing based or annealers or other things, that is not outside India. We are so much, casteism is so much embedded. We always make this one is a higher class, this one is a middle class, this one is a lower class. So when I hear this from respected professors, I feel very bad, and very bad because this is how, if you want to run India, that's why, I mean, in next 100 years you will never get a Nobel Prize from India, because the problem is the mindset is not understanding the principle and breaking the principle. For an example, just a few days back I had a huge debate with a professor regarding quantum. I mean, we are making quantum annealing based quantum computer, and we are solving only one problem, that is classification problem. Classification problem means you have, like YouTube, people are uploading dirty and illegal, bad videos but Google cannot search and classify them into different parts. So classification is one of the fundamental problem that is dangerously hurting the human civilization. For an example, cloud. What kind of cloud is there so that you can predict the cloud burst? It's a big problem for ISRO. So we want to solve that one. So I talked to some of the ISRO scientists, and then we negotiated and we tried to solve. So classification is a problem where you can classify good from the bad, worse from the others. So that is the only problem we are targeting in making the quantum computer. So classification problem, class of problem, quantum annealing, and logic gate we will show, because otherwise we don't become Brahmin, we will be untouchables. So so I know that those who are making quantum gateways, it's an open challenge to them. That whole world is not able to do it. You will also not be able to, not even a single gate. I mean, it will be recorded, you will see it, but they will always disown. Oh, that is kind of a bad thing. So those bad things, we are going to be the bad guys in India. So quantum annealing based or adiabatic computing, adiabatic quantum computing it is called. So what happens is we can grow one molecule into large supramolecule, and that will be the quantum circuit. So we take the input information. For an example, I'm looking at you. What I see in your conversation a particular pattern which is repeating like a clock. And those pattern I take. So we have created a very, very complex software, massively complex. So I told you, classical computer needs 1 billion lines of codes. In a quantum computer, you need that level of complexity. So we have already built it in Japan. And Professor Behera came here, had talked to our president, and then invited him to be part of it. And then in a proper technology transfer, proper way, everything is going. And then we are, the way we are planning in India, it is many, many times more than what we built here, because I don't want to create just a replica, so that I don't want to waste my time, right? So I will definitely try to do, and I also don't feel that where Japan invested money for years and then built something, India will replicate it just like the filthy China. As an Indian, I will feel very bad. True. Very bad. True. We do not replicate. We create and so much innovation. So I am teaching the principles to the students so that they can come up with a creative idea and make 100 times better than what I have built in the last 18, 19 years. So that will be my success. So definitely I can assure you that under any circumstances, it will never, ever, ever be replica, or even 1% will not be taken from the Japanese resources. Even though we are saying we are collaboratively will build, we will share some percentage to the Japanese institute and something, still we will not take anything. So room temperature, optical quantum computer, it's a topological system, and there will be 16 channels, and topological hierarchical quantum computing, where we will show around equivalent to, we are making GPU, graphical processing unit. People make CPU. We are not making quantum CPU, because quantum CPU means I need to make the hierarchical clock architecture to control the time evolution at all the processes. And that is where nobody in the world is talking, because nobody is serious about making, just like brain research 2014, nobody was serious about making the brain. So they never answered 4 questions: that what is information in the brain or the universe, what is the unit device in the brain or the universe, how information integrates, and what makes it self-aware. So when you are 86% you can emulate of the whole, then in my part, then, and I am whole of those parts that are inside me, 86%, my 86% they can analyze, then I am conscious. So like I give direct answer, it could be wrong, right, other thing. And I'm telling you with full responsibility that unless until hierarchical quantum clock architecture is built, where you can keep the time at every different layer, you can never, ever, ever build a quantum computer. And quantum error correction also hierarchical network, because it will go away, because you can't make where. So another good thing about this computer that we are building in IIT Mandi is that there is no wearing. So we are using the beauty of shared existence, you said. With that, I would like to end it, this interview, that you said that shared existence has a beauty, because if your existence, somehow I can share it at many places, I don't need to communicate and ask every part what has happened to you. I can, I do not break the entanglement. I just manipulate the symmetry and I can understand what is going on. So I have 16 channels. At the end, I will show you the quantum computer that is here, and people should see it. And it's not running right now, but this is it. If there is a problem, tell me. So this is the computer which is now off, I think. So there we program it, and we send 16 different replica of the same problem. And this is the organic jelly where the single supramolecule goes, or quantum circuit is synthesized for every single problem. And there is the photon source, single photon source. We check it here. This is a single photon source. It divides into 16 parts. There are optical fibers, which takes, and you will find that C2 symmetry, C7 symmetry, C13, C5. So different gel looks into different symmetries of the quantum collapse and try to investigate. And here is a picoquant machine. We are using 16 channel. So 16 different symmetries we look into. So we don't look into different number of qubits, because qubits are hierarchical topology for us. So around 5,500, 800 to 5,000, in between that, equivalent qubits would vary at the final, but we cannot compare because we are making quantum GPU. So that is one part of it. So basically we take graphics with a graphical processor we want to build. So it's not a classical computer like quantum computer where you type and do. With a camera, you have to show the video of any unknown data. Immediately, instantly, it will tell what is the model, what is the hidden model into it. So that is going to be the thing. And another thing I must say before I end, quantum computer, classical computer you build because you mastered the technology of quantum mechanics. Classical computer doesn't run with classical devices. There are classical wiring circuits. Principle is classical, but the devices are all quantum. So if you want to make quantum mechanics, a quantum computer, truly quantum computer that has not been designed, I mean, we think that we are trying to design and build a true quantum computer, then you need to go one level higher than quantum mechanics. That is, we proposed long back, fractal mechanics, which Roger Penrose and many others are saying. Whether we will be successful making an absolutely ideal quantum computing or not, that is a future question. And the answer lies whether we will be able to master the fractal mechanics, which is one level beyond, because from where quantum mechanics could be derived, because quantum mechanics is observed, none of its theories are derived from some basic postulates or principles. Those are we have taken and fitting equation that we have put. Everybody knows this. Many scientists have contributed. I'm not going to contribute over that, but technologically, what I'm trying to see is just by manipulating the symmetries, can I have different part of the block sphere or the unknown mysterious territory, I can classify and find multiple worlds or multiverses that you say, and we can engineer over there to change the quantum world. So one level above to the quantum world, and then we do it. So two things: hierarchical clock architecture, hierarchical quantum error correction, and one level above the quantum mechanics, another mechanics and another engineering of symmetries or breaking symmetries needed to build a quantum computer.
Doctor, really appreciate you taking time and being part of the podcast. Truly honored to have you on the podcast, and you shared so much insights. I hope that you play a pivotal role in shaping India's quantum mission, and wish you and your team the very best. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Bye-bye. Thank you, Doctor. Really appreciate this.
Okay.